Here's topic 3.4 in Math 30-1. This is Equations and Graphs of Polynomial Functions, Part B. Graphing polynomial functions using transformations. This ties in with what we did in chapters 1 and 2, and since it's the last topic in chapter 3, it's fitting it all comes together. The graph of a function of the form of a times b times x minus h all to the power of n plus k is obtained by applying transformations to the graph of general polynomial functions y equals x to the power of n, where n is any natural number. The effects of changing parameters in polynomial functions are the same as the effects of changing parameters in other types of functions. And what does that mean? Well, we have different parameters. The parameter k, first of all, is going to be in control our vertical shift up and down, our vertical translation. xy, every point x and y in our graph is going to go to x and y plus k. Next is our h value, and our h, of course, is going to be our horizontal translation, left or right. Every x coordinate now is going to be adding h onto it. A is, of course, our vertical stretch, and it's going to be about the x-axis by a factor of the absolute value of a, and then there's a further reflection in the x-axis if a is negative. For b, we can say that the horizontal stretch is about the x-axis by a factor of 1 over the absolute value of b. For b is negative, the graph is also reflected in the y-axis, and every point xy goes to x divided by b and y. Lastly, to obtain an accurate sketch of a transformed graph, apply the transformations represented by a and b first. Those are the reflections and stretches before the transformations represented by h and k, which are, of course, our slides or translations. Let's look at this example 3. Applying transformations to sketch a graph. First of all, we have the points on our graph. How did we get those? We used x values of -2, -1, 0, 1, and 2. Plugging them in to our equation, we found that the y values were -8, -1, 0, 1, and 8. Now then, when we plug this in, we look at it, and we're going to say, okay, now the first thing is a horizontal stretch by a factor of 4. So -2 is going to be divided by 4 to get the point -0.5 and -8. The y value doesn't change, and we're going to be dividing each of our x coordinates by 4. That way, you're going to get -0.25 and -1, 0, 0. This one's going to be divided by 4 to get 0.25 and 1, and divided by 4 is going to give me 1/2, or 0.5 and 8. Whoops, that went way too far. The next thing is to look at a vertical stretch of -2. That means my y coordinate now is going to be multiplied by -2. Starting with -8 times -2, I'm going to have a y coordinate of positive 16. In the next one, the x coordinate stays the same, of course. -1 is going to be multiplied by -2 to give me positive 2. And it's going to be the same for all of those points down there. In the next part, we have a slide. The x coordinate is going to move 1 coordinate to the right and 3 units up. So the x coordinate is going to go 1 to the right, so -0.5 becomes positive 0.5, and 16 goes to 19. In the next point, -0.25 is going to add 1 to that to become positive 0.75, and 2 is going to be added 3 onto it to get to 5. And the other points are going to be the same. Now, when it asks me to sketch the graph, I'm going to put the original graph down, and I'm going to put my new graph, and that's going to be, there it is. If you look at it, you're going to see that the original graph is just y equals x cubed, and now it's been transformed by a vertical stretch of -2 and a horizontal stretch of 1/4 or 4 and a shift of 1 unit to the right and 3 units up. Your turn. Transform this graph. Again, picking the points, -2, -1, 0, 1, and 2. We're going to start out by doing, we'll do the b. This time, 2x cubed is going to give me these points. All I'm doing this time is dividing each of my x values by 2. Now I'm going to apply the vertical stretch of -4. So every y coordinate is going to be times by a -4. And -8 becomes +32, etc. down the line. Next is my last thing I'm going to do, and that's going to be a vertical shift and a horizontal shift. The horizontal shift is going to be 2 to the left, so I'm going to subtract 2 from every x coordinate. And I'm going to subtract 5 from every y coordinate. So the first one is going to be -3, and when I subtract 5, I'm going to get 27. Oh, I'm going to do all the x's first. And that's how I'm going to get those points. Graphing it, plotting points, and connecting the dots, and that's what I'm going to see. So to graph, all you have to do is plot those 5 points, connect the dots, and see where to draw the line through. In example 4, Bill is preparing to make an ice sculpture. The block of ice is 3 feet wide by 4 feet high by 5 feet long, and he wants to reduce the size of the block by removing the same amount of ice from each side. So if you drew it, you would have something that would be 3 by 4 by 5, but then to take the same amount off of each side, and we don't know how much to take off, we would say it would be 3 minus x, 4 minus x, and 5 minus x for the dimensions. There's a picture of it to the right. Write a polynomial to match this. Well, we know that volume is length times width times height, and we know what the length and width and height are. Those are 5 minus x, 4 minus x, and 3 minus x. And we know what the volume is. The volume, we're told, is going to be 24 cubic feet. So we can say 24 is 5 minus x times 4 minus x times 3 minus x. Now I can expand, simplify this, subtract 24 from both sides, and get a quadratic equation setting equal, not a quadratic, but a cubic equation with a set equals to 0. And I can solve it using the methods that we learned in this chapter. Or I can say y1 is equal to my left side of 24, and y2 is equal to the right side. And then I can plot these points. I can draw the graphs on my calculator and find the intersection point. And when I find the intersection point, the x-coordinate is going to be the answer that I'm looking for. And since x is equal to 1, 1 foot should be removed from each dimension of length, width, and height. There it is there. Your assignment is to do page 148, numbers 5 to 11, 15, 16, and 18.